Hello dear students, welcome to Konar classes. In this session we are going to solve 3 questions on linear differential equations. Okay, so let's start one by one. The first question, as you see in this board, find the general solution of the differential equation x dy dx plus 2y equal to x square. Okay, so what is the differential equation? X dy dx plus 2y is equal to x square. Now we must divide both sides of this difference equation by x. So from there what we get is that dy dx plus 2 by x into y is equal to x square by x is x, and we are able to divide by x as x is not equal to 0. Correct? Now dear students, what we see is that this is a linear differential equation, as if this 2 by x is equal to p. If you recall the linear differential equations, dy dx plus py is equal to q. So this x is as if q and 2 by x as if p. So what is the integrating factor? So integrating factor we get, dear students, is equal to e power integration p dx. That means integration 2 by x dx. So this is equal to e power integration. So 2 is constant, we take outside of the integration, dx by x. What is integration dx by x? That is equal to log x. So that is equal to e power, what we get, dear students, e power 2 into log x. Okay, 2 log x is equal to log x square, from the properties of logarithm. So e power log x square. E power log x square is nothing but x square, correct? So we get this is equal to x square. Now what we are going to do is that as we get that integrating factor as x square, so what is the solution to this linear differential equation? This implies that y into integrating factor, y into x square, is equal to integration q, that is x, into that integrating factor x square dx. That is the solution to the linear differential equation. Okay, and you can add one integrating constant called c1. Okay, so from here what we get, dear students, so this implies y x square is equal to, it is x cube dx, that is equal to x to the power 4 divided by 4 plus, because of this indifferent integration we will get one integrating constant, so that integrating constant added with c1 to get a new integrating constant called c. Okay, so this is the solution to the differential equation, or you can simplify one step further. This implies if we divide both sides of this equation by x square, we get y equal to x square by 4 plus c into x to the power minus 2. So this is the solution to the given linear differential equation. Okay. Now let's proceed to the next question, dear students, and next question I am going to write it here. And as I always say, dear students, please do along with me, okay? And in case you want to know that how come e power log x square equal to x square, that is very fundamental. Please follow my classes on logarithm, you will get clear. Okay, very clear idea about it. Okay, now let's proceed to the next question. So let me write down the next question from my notebook. Okay, and here it is. Question: find the particular solution of the differential equation. Find the particular solution of the differential equation dy dx plus y cot x is equal to 2x plus x square cot x, and it is given that x is not equal to 0. Now as it is given that find the particular solution, definitely there must be an initial condition given. So what is the initial condition? So it is written here, given that y equal to 0 when x is equal to pi by 2. That is the initial condition. Let us find a solution to this differential equation, dear students. Okay. So what we see, this differential equation dy dx plus y cot x equal to 2x plus x square cot x. So this is definitely in the form of dy dx plus p into y. What is p? This is as if like p, correct na? And that is equal to q. So this is as if like q. Okay, if you recall my previous session on linear differential equation, you can follow that lecture as well. Dy dx plus py equal to q, where p and q are either constant or function of x only. Then how to solve it? First we need to find the integrating factor. What is integrating factor? E power integration p dx. What is p here? Cot x dx. Okay. So this is equal to, if you recall, that integration cot x dx is nothing but log sin x, correct? So e power log sin x. Now e power log sin x is nothing but sin x, correct? So now as we found that integrating factor as sin x, what is our next task? Next task is that to find the solution to this differential equation. So what is our differential equation? This is the differential equation, right? Dy dx plus y cot x equal to 2x plus x square cot x. So from here what we are going to get is something like this. So solution to this differential equation become y into the integrating factor, that is sin x, okay, is equal to, what is q? 2x plus x square cot x, okay, into sin x dx. Why into sin x? Because we need to multiply q with the integrating factor, that is sin x, and integration. Now what about the solution to this integration is the solution to the given differential equation. And once we get that integrating constant, we will apply the initial condition, that is x equal to pi by 2 and y equal to 0, to find the value of this integrating constant, and we will end up with a particular solution. Okay. As we complete this integration, there will be one integrating constant, but for the sake of simplicity we are not considering that, but finally we will get a final integrating constant and we will find the value of it, okay, by applying x equal to pi by 2 and y equal to 0. Now let us concentrate to integrate this one. So from here what we get, dear students, this implies y sin x is equal to integration 2x sin x dx. Integration, so 2x sin x, so 2 we can take outside of the integration, so x into sin x dx plus x square cot x into sin x. Cot x into sin x is what? Cos x. So this is equal to integration x square cos x dx. Obviously sin x is not equal to 0, that's what we are able to do it. And why sin x is not equal to 0? Because x is not equal to 0, it is given. Sin x not equal to 0, that's why we are multiplying cot x into sin x, na? Because cot x is equal to cos x by sin x, that cos x by sin x is cancelled with the sin x, and that cancellation is only possible if sin x not equal to 0. Very fundamental mathematics, but important. Now let us concentrate on finding the value of this integration first. Let's see. Okay, let's find the value of this integration. How we are going to find it out? Using the integration by parts. Okay, so let me do it here. So this is equal to, now between x square and cos x, which is the first function according to the Euler rule of integration by parts. So x square becomes the first function, and cos x becomes the second function. Okay, if you want to know about the integration by parts, please follow my lecture on integrals. Okay, it is available in YouTube, by the way. So this is equal to what, dear students? So this is equal to x square integration cos x dx minus integration ddx of x square, correct? ddx of x square into integration cos x dx, and this entire thing is actually integrated, correct? That is the integration by parts. So this is equal to what we get, dear students? So integration of cos x is what? Sin x. So we get x square sin x minus integration ddx of x square, that is 2x. So we get 2x into integration of cos x dx. Integration of cos x dx is sin x. Sin x dx. So what we get, dear students? So this is equal to x square sin x minus 2 into integration x sin x dx. Okay, because 2 we can take outside of the integration because it is a constant. Okay, now what we see, this value of integration x square cos x dx, we are going to apply it here. Okay, and let's include one integrating constant here, that's c, and that value of c will bring it here. So this implies what, dear students? So we get y sin x is equal to 2 into integration x sin x dx, okay, plus x square sin x minus 2 into integration x sin x dx plus one integrating constant c. Now if you notice that 2 integration x sin x dx minus 2 integration x sin x dx will get cancelled. So what we get, dear students? So from here we get y sin x is equal to x square sin x plus c, x square sin x plus c. And this is what, dear students? This is, the general solution, primitive, or the family of curves represented by this differential equation, the way you want to name it. We need to find the particular solution, and to get the particular solution we need to find the value of this integrating constant c. And how we are going to get it? By applying this initial condition x equal to pi by 2 and y equal to 0. Okay, so if we apply x equal to pi by 2 and y equal to 0, what we are going to get? X equal to pi by 2 and y equal to 0. So what we are going to get from here then? So y equal to 0, so 0 into sin pi by 2, that will become 0. 0 equal to, so this implies 0 equal to x square, that means pi square by 4. Pi square by 4 into sin pi by 2. Sin pi by 2 is 1. So I am not writing here anything. Pi square by 4 into 1 is equal to pi square by 4 plus c. Correct? So from here what we get, dear students? So from here we get the value of c is equal to minus pi square by 4. Now that value of minus pi square by 4 we will apply here. Okay. So what will be our particular solution? So the particular solution will be something like this. This implies y sin x is equal to x square sin x minus pi square by 4. We can simplify further by dividing both sides by x sin x. So from here what we get? Y is equal to x square minus pi by 4 sin x, and this is the required particular solution. Okay, that is equal to y equal to x square minus pi by 4 sin x is the particular solution to this given differential equation subject to the given condition y equal to 0 when x equal to pi by 2. Okay, now let's look into the next question. That is the last question for today's session. Okay. Once this session is very well you looked into, then please log into the online test platform at konarclasses.com and solve some relevant DPPs, daily practice problems. Once these daily practice problems are done, then you can appear for practice test that we call as PT. After that you can appear for unit test that is called UT. After that you can appear for module test that is called MDT, and finally appear for mock test. In this way, if you prepare, you will see in your final examination you will not find any question which is not common to you. Okay. So the last question for today's session, I am going to write it here. Find the equation of a curve passing through the point 0, 1. So find the equation of a curve. Find the equation of a curve passing through the point 0, 1. Passing through the point 0, 1, if the slope, I can write it here comma, if the slope of the tangent to the curve, if the slope to the tangent, slope of the tangent to the curve at any point xy, at any point x, y is equal to the sum of the x coordinate, is equal to the sum of the x coordinate, and you know, dear students, x coordinate is known as abscissa. And the product of the x coordinate and the product of the x coordinate and y coordinate y coordinate is known as ordinate. Of that point. Okay. So let us first understand what is that, meaning of that question. Find the equation of a curve passing through the point 0, 1. If the slope of the tangent to the curve at any point x, y. Okay. So what is meaning of this particular statement? The slope of the tangent to the curve at any point x, y. The slope of the tangent to the curve at any point x, y is nothing but dy dx. Okay. If you follow my classes on application of derivative, you will get a clear idea why it is dy dx. Now that dy dx is equal to the sum of the x coordinate, that means as I proceed, let me write it down. This is equal to x coordinate is x, na, plus, because of sum I wrote the plus, and the product of the x coordinate and y coordinate of that point. That means it is equal to x plus x into y. Okay. So all you need to find is that solution of this differential equation, and that will give us a general solution or primitive. Now from that we will apply this initial condition is passing to the point 0, 1, and we will get a particular solution, the particular equation of the curve. dy dx, okay, minus x into y is equal to x. If you recall, the dy dx plus py equal to q, as if this is p, correct, and as if this is q. Okay, dy dx plus py equal to q, linear differential equation. So first one you need to what you need to find? First you need to find the integrating factor. What is this integrating factor? E power integration p dx. What is p? Minus x dx. So you can take this minus outside of the integration, x dx. Correct? So what we get? E power minus integration x dx. This is equal to what, dear students? E power minus x square by 2. So this is our integrating factor. Now as we found the integrating factor, so what is the solution of this differential equation? The solution of this differential equation, what we can write is that we can write as y into the integrating factor, y into e power minus x square by 2, okay, is equal to integration q. What is q? Q is x into the integrating factor e power minus x square by 2 dx. Alright. Now all you need to do is find the value of this integration, and after that we will get the solution. Okay. So how to do this thing? By the way, there will be one integrating constant. I am not writing it. I will write finally once we solve this integration. All you need to do is, dear students, is to find the value of this particular integration. Okay. How to solve this integration? Let's now concentrate on this. So for that, dear students, what we can write is that we can take x square by 2 is equal to t, or minus x square by 2 equal to t. So let minus x square by 2 is equal to t, the substitution. We will differentiate both the sides. So that implies what, dear students? Minus 1 by 2 into 2x dx is equal to dt. That means what, dear students? X dx is equal to minus dt. So this implies x dx is equal to minus dt. Okay. So then what we are going to get, dear students? So from here, as we substituted this value, so this integration is now become integration x dx is equal to what? Minus dt. So minus we took it outside, and e power minus x square by 2. That means e power t dt. What is e power t dt integration? That is e power t. That is equal to minus e power t. Here we are writing that integrating constant c. Now what is t? We need to apply back the value of t, because it was our assumption t equal to minus x square by 2. So what we get, dear students? So here minus e power minus x square by 2 plus integrating constant c. So dear students, so what we get? We get the solution to the given differential equation. We get it something like this. So from here I am writing. So this implies y into e power minus x square by 2. So I am writing it here, minus x square by 2 is equal to minus e power minus x square by 2 plus the integrating constant c. Correct? So now, as this general solution or family of curves, that is the solution to the given differential equation, okay, is passing through the point 0, 1. That means what? At x equal to 0, y is equal to 1. So we should apply this value here. What we are going to get? Y equal to 1 into e to the power minus 0 by 2. That means e to the power 0. E to the power 0 is equal to 1. So 1 into 1 is equal to minus e to the power 0 minus 0 by 2 is 0. So that is equal to minus 1 plus c. So from here we get the value of c is equal to 2. Correct? So now this value of c equal to 2, we are going to apply it here. This one. Okay. So what we are going to do now? So from here we are going to apply that value of c is equal to 2. So what is the solution to the given differential equation we are going to get? This implies y into e power minus x square by 2 is equal to minus e power minus x square by 2 plus the integrating constant value we got 2. Okay. For further simplification, what we can do? We can multiply both sides by e power x square by 2. Okay. So from here what we get, dear students? Y is equal to so here e power x square by 2, that is equal to minus 1 plus 2 into e power x square by 2. Okay. Or we can write from here that y plus 1 is equal to 2 into e power x square by 2, and this is the solution to the given differential equation. If you look into this problem, this was a problem statement. From that problem statement we form the differential equation. That is important. In a exam hall you will get a question something like this. Now your task is to go through this problem statement and interpret it as a differential equation, and that is only possible if you make relevant practices, and for that you need to log into the online test platform at konarclasses.com and perform maximum practices. With this note, let me conclude the class here, dear students. Thank you. Bye bye.